Hello, it's Tuesday, May 12th, day 4 of logarithms, and the last lesson for Accelerated Algebra 2. So just think, I'm posting this on May 12th, which gives 10 days to get caught up if you're behind, with nothing new that will be assigned. So remember, I'm always available. If you have questions on anything, just shoot me an email. I might be able to explain it in OneNote, or we can always Zoom. Okay, so we're going to review properties today. The solving is going to get just a bit more complicated. So remember, when you have addition, it goes back to multiplication. You're going to have to remember how to condense these things. So log xy. So you can have a single logarithm when you're solving. When it is subtraction, it goes to a single logarithm where the argument is being divided. Okay, so oftentimes I see this written like this. And that is absolutely incorrect. Notice I have a single natural log or a single logarithm. Only one. Okay, so this one, my arguments are a little bit more complicated. So I get log base 3 of first argument x times 2x plus 1, going from addition to multiplication. Then I could simplify this to get my argument in a little better form, 2x squared plus x. So hopefully you realize you're going to see some quadratics maybe today. Okay, so this last one, I do have division, but I also have a constant sitting in front of the logarithm, which means that goes back to a power. So this one to be condensed would be a log. And the argument x squared plus 1, or x plus 1, the whole argument is being squared. And on the bottom, I would have 2 to the third, which I could simplify to 8. Okay, so that argument's a little bit complicated, but honestly, when I set it equal to something, it's not going to be that terrible to solve if you know your properties. All right, so a few things on this one. Okay, so remember that you have to think about domain restrictions when you're solving a log. So first thing you do is I say 3x has to be greater than 0. X has to be greater than 0, so that's part of the argument, or the domain. And here it's easy enough to see that x has to be greater than 4. So the entire domain takes on the most important one. So my domain on this one is x has to be greater than 4, because it has to satisfy both. This problem should not be here. We only have 2 on this page. All right, so this is addition. So remember, my arguments get multiplied. So log base 6 of 3x times x minus 4 equals 2. So this is going to get distributed in here, so I'm going to end up with a quadratic. So I'm going to go ahead and change to exponential and distribute that 3x at the same time. So 6 squared equals 3x squared minus 12x. So we're solving a quadratic. Some of us forget what we need to do in order to solve a quadratic. We have to set it equal to 0. So I know 6 squared is 36, so I get 3x squared minus 12x, and I'm going to subtract that 36. So now my quadratic is equal to 0. Then guess what? We're going to factor. Always look for GCF first. It might save you some time. So on this one, I can factor out a 3. So I get x squared minus 4x minus 12. And then that makes this piece of the quadratic much easier to factor because I had a leave coefficient of 1. So I get 0 equals 3, multiply to negative 12, add to negative 4. It should be a 6. I say 4, I write 4. So minus 6 plus 2. So when I divide by 3, it's not going to change the 0. So I get x equals 6. Should be an x plus 2. And x equals negative 2. So now you go back and look at your domain. Remember, x has to be greater than 4. Well, this one works. This one does not. So this one is an extraneous solution. It is not in the domain. Right here, if I say x is equal to negative 2, well, if I plug it in here, I'm going to get log base 6 of negative 6. And remember, the argument has to be greater than 0. All right, so for this one I don't have any properties to apply. But I do know that x has to be greater than negative 1/3. So if I subtract 1 and divide by 3, I get negative 1/3. So this is base 10. So I get 10 squared equals 3x plus 1. This is a little easier than the other one. That's equal to 100, and 100 minus 1 is 99. So in this case, x is equal to 33, which is in the domain. Okay, so again, whenever you have a logarithm, you always check your domain restrictions first. All right, 3 more. Okay, so this one, x has to be greater than 0. This one is already a constant, so I don't have to worry about that one. Okay, so the first thing I see is this constant sitting in front of this logarithm, so I need to bring it back to an exponent. I need to condense this side to a single logarithm before I change to exponential. So since it's addition, I'm going to be multiplying my 2 arguments. So I have log of x squared times 4, which is 4x squared, equals 2. So I multiplied my 4 and my x squared. So now this is base 10. Looks like I've given you all of these as common log. So I get 10 squared equals 4x squared. Now I'm just solving, keeping in mind my domain restriction. So 10 squared is 100, divided by 4 is 25. So x is equal to the square root of 25, and you have to remember your positive negative. So positive negative 5. So now you go back and check your domain. X has to be greater than 0, so this one works. This one is extraneous. You always can get false solutions when you have domain restrictions. You can get false. You don't always get false. All right, so one last one, or second to last one. So right here, I need to say x is greater than 0 again to keep that in mind. So this is subtraction. I have no constants to worry about, so I condense to a single log. Subtraction goes back to division. Now I can change to exponential. So I get 10 to the first equals 5 over 2x. If I multiply both sides by 2x to solve, I get 20x equals 5. Divide by 5, I get x equals 5 over 20, or 1 over 4. Check my domain. X has to be greater than 0, and 1/4 is greater than 0. So I should be good as long as I did the math correctly. All right, one last one for a challenge. Okay, so this one's a little weird because I have this constant sitting over here. So the first thing I need to do is gather my logarithms on the same side. So I have 7x plus 1 minus the log of x minus 2 equals 1. Now I have my logs on one side and my constants on the other. So here my domain, x has to be greater than negative 1/7. Here my domain, x has to be greater than 2. So this one overtakes this one. Because if my x is greater than 2, then it's also greater than negative 1/7. So there's my domain restriction. Okay, so now I have subtraction, so I need to combine those arguments to a division problem. So the log of 7x plus 1 over x minus 2 equals 1. So I have base 10. So I have 10 to the first equals 7x plus 1 over x minus 2. So now I'm solving a rational. So to get rid of that denominator, I multiply both sides by x minus 2 times x minus 2. I have to distribute. These are going to cancel. So I get 10x minus 20 equals 7x plus 1. Then I'm down to just a basic linear equation that I'm solving. Okay, so if you could see me right now, I'm getting a little emotional because this is the last example that I will do with you as an Algebra 2 student. I might get lucky and get some of you back in trig. We'll see. Okay, so 7x, subtract 7x. And I'm going to go ahead and add the 20 to gather my constants on one side and my variables on the other. So I get 3x equals 21. And to end on a strong note, I get x equals 7. So then always go back to make sure that it's in the domain. X is greater than 2. Last I checked, 7 was greater than 2. So that answer should be good to go. All right. Notes are posted. Assignments posted. I'll be probably setting up some extra PFA times for those of you that might need them. You have 10 days to get finished with everything. Some of you are already done, so congratulations. And let me know what I can do to help. It's been a great semester, even though I got to only see you for half of it.